Welcome to the Altai Network Planner tutorial. Altai Network Planner is a powerful web-based tool designed for Wi-Fi network design, analysis, and simulation. It allows engineers to visualize coverage, plan access point placement, and predict wireless signal coverage based on real physical environments. With the Altai Network Planner, you can upload building floor plans, define wall materials and obstacles, perform RF signal propagation simulations, and quickly assess signal coverage at both 2.4 GHz and 5 GHz frequency bands. The tool helps you to optimize AP locations, orientation, and power levels before any hardware is deployed, saving both design time and installation cost. In this video, we will walk through a complete indoor planning scenario demonstrating 1. How to import and scale a floor plan. 2. How to define the indoor environment and wall materials. 3. How to place Altai access points and network switches. 4. How to run coverage simulations and interpret the heat maps. 5. How to export the bill of materials and project report. After watching this video, you'll be able to use Network Planner effectively to model real indoor spaces, evaluate signal coverage and identify weak zones, generate professional simulation reports and material lists for project documentation. After signing in, click Network Planner button. On the main interface, select Open Network Planner and create a new project. Enter a project name, for example, Indoor Office Project, and provide a brief description such as Indoor Wi-Fi Deployment Simulation. Click Confirm. Next, create a floor plan within your project. Click Create Plan, then provide a name of the plan, for example, Indoor Plan, and ensure height simulation is enabled. Now drag and drop your floor plan image into the import box or browse to select the file. You will then be prompted to choose Dense Space Simulation or Sparse Space Simulation. A dense space refers to indoor environments filled with numerous obstacles that are not explicitly represented on the map. Typical examples include offices, restaurants, auditoriums, low-ceiling spaces. A sparse space refers to indoor or outdoor environments that are spacious and have obstacles explicitly drawn on the map. Typical examples include large warehouses with racks shown on the map or high-ceiling spaces. In this typical office environment setting, we will select Dense Space Simulation, as we will only partially specify obstacles and skip defining the partition walls. Once imported, define the scale of the drawing so the tool understands real distances. Click Set Scale, mark 2 reference points, and enter the actual distance, for example, 50 meters. Click Confirm to apply. Next, define the heat map simulation area. This is the zone where signal coverage will be simulated. Drag a rectangular area covering your deployment zone. Now let's represent the indoor environment using wall materials. Select the drawing tool and add walls corresponding to your layout. You can choose different material types: concrete, drywall, glass, metal, or wood, each with its own RF attenuation characteristics. For example, use glass walls for perimeter partitions. Use drywall for internal rooms or cubicles. Use metal walls for structural barriers such as storage or mechanical areas. Walls can be drawn line by line or as rectangular areas. To adjust any wall section, use the Select tool to move or modify its position. Once the floor plan is defined, we can place Altai access points. Click Edit AP List and select the AP model appropriate for indoor use. In this example, we'll use the following models: Altai i760, ceiling-mounted AP with omnidirectional antenna; Altai iX600, compact indoor AP; Altai C260S, wall-mounted AP with directional antenna. Example placement process 1. drag an I-760 onto the floor plan. Set height at 3 meters. 2.4 GHz and 5 GHz, TX powered 12 dBm. Tilt angle 90 degrees. Let antenna face downwards, hence representing ceiling mount. 2. Duplicate and position 2 to 3 more I-760 as needed for coverage. 3. Add an IX600 to cover the corridor area. Set similar parameters but with TX power 10 dBm. 4. Place a C260S near a wall. Set mounting height at 2 meters. Set TX power at 10 dBm for both 2.4 GHz and 5 GHz. Tilt angle 20 degrees. To complete the topology, let's add Altai Network switches. Select MES 200, which is an 8-port managed switch, and place it near the AP cluster. Then use the cable tool to draw Ethernet links between switches and access points. Duplicate another switch if required for remote zones. Once all the devices are placed, review antenna orientations for 2.4 GHz and 5 GHz radios. For omni-antenna access points, like I-760, IX600, orientation has little impact on signal coverage. However, for C260S, adjust the directional beam to aim toward target coverage zones. To visualize coverage, select 2.4 GHz, simulation or 5 GHz simulation, and generate the heat map. Different colors represent signal strength: green for strong, yellow for moderate, red for weak. Analyze the map and identify areas that need improvement. Once satisfied with the simulation results, generate a BOM. Click BOM, and the planner will automatically list all deployed AP and switch models, along with power sources and antenna details. You can export results in PDF or CSV format. Additionally, export the simulation report. It includes floor plan snapshots, heat maps for each frequency band, and a summary of device parameters. For backup or collaboration, export the project as a JSON file or save it to cloud storage. This concludes our walkthrough of Altai Network Planner for indoor environments. We've covered the complete process, from importing floor plans and defining structures to placing access points, running simulations, and exporting reports. Follow this same workflow to model various indoor scenarios and optimize coverage for different Altai access points. Thank you for watching.